Okay, so the question is, what is acid rain? Have you ever been in acid rain? Well, the answer to that question may surprise you because there are a lot of people that have misconceptions about acid rain. A lot of people think it might be something as drastic as these cartoons. But, well, it's fortunately and unfortunately. Fortunately, it is not as drastic as we see in these cartoons. And however, because it is not as drastic as we see in these cartoons, people are often less likely to do something about it. And it is and can be a major problem. Now, this is one environmental issue where there's actually some good news about, but we want to make sure we understand the issue of what acid rain is. Okay, now, we need to understand to start with that normal rain, and by normal rain I mean non-polluted, not acidic rain. Let's go back 2,000 years ago before man did a lot of stuff to the environment. If we were to look at the rain there, we would find that it was slightly acidic. Okay, so normal rain always has a pH a little bit less than 7. But what we officially define as acid rain, and again, if you did a good job, as we go through this PowerPoint here, if you did a good job answering the questions to your acid rain article, you should already have these things written down. So you'll see on this PowerPoint, I referred to certain question numbers and certain pages. You should already have these written down. So as you're watching the video, feel free to pause the video, compare what you're seeing up on the screen and what I'm saying to what you have written down, and if need be, add some additional things, because your answers to those questions are your notes to what we're doing with acid rain. So acid rain is officially defined as rain that has a pH of less than 5.6. We said naturally rain might be 5.8, 6.2, and that's not too much of a problem. But what we find is when that rain gets a pH of less than 5.6, that it starts to cause environmental problems. And we don't see this happening on a very large scale until man's activities. So acid rain on a large scale is a man-made thing. We do see it in local pockets, like near volcanoes, where some of the hydrogen sulfide gets a little pocket of highly acidic stuff, but not on a large scale. Now remember, the cutoff is 5.6. If you're less than that, your acid rain. pHs, average rainfall, guess what? 4.3. So yes, it definitely is a problem in Pennsylvania, has caused a lot of problems, and as we see when we take a look at the map, Pennsylvania is one of the most affected states. It's because we've got industrial areas around us no matter which way the wind is blowing. So we first want to take a look at what is it that causes acid rain, and this you should have answered in number 8 on page 49. If you were to answer in 3 words, if I were to ask you what causes acid rain, the short answer to that question is burning fossil fuels, burning coal, burning oil, burning gasoline. Now we want to understand the process behind that. So we've already said that burning fossil fuels are combustion reactions, and we know that combustion reactions, our products are always, water and carbon dioxide. However, there's other things that result either due to impurities that are in the fossil fuels or due to non-ideal conditions of the burning. And 2 gases that are often produced in addition to the carbon dioxide and water when we burn fossil fuels are nitrous and sulfur oxides. Now sometimes we get nitrogen dioxide, sometimes it's nitrogen monoxide, so we generically refer to them as NOx gases, where the X just stands for any variety of those nitrous oxides. And the same thing with the sulfur oxides. Sometimes you get sulfur dioxide, sometimes it's a sulfur trioxide, so we just generically refer to those as the SOx gases. So burning fossil fuels often emits these NOx and SOx gases. And if you're concerned with the pollution of certain places and you're monitoring the pollution, one of the big things you would be monitoring is your NOx and SOx emissions. So what happens, these are not acids, these are gases. And these gases, since they're gases, they rise up into the atmosphere, and up in the atmosphere they come in contact with some other gases that are up in the atmosphere. Now, one of the things is gaseous water that is up there. And so what happens is your nitrous oxides, and here's an example here, we're using NO2. It combines with water, and you should be able to finish that equation. And in this case, it makes nitric acid, which is a strong acid. The sulfur oxides can go to combine with water, and they're going to make a combination, sulfuric, sulfurous. Of course, sulfuric is the strong one, so that's the important one there. So this is essentially how acid rain is formed. It's by burning these fossil fuels, all those NOx and SOx gases getting up to the atmosphere, they combine with water to make nitric and sulfuric acid. Those are your main acids that are involved in acid rain. Now, why is this a problem? It's highly dilute, so it's not like the rain hits your skin and makes your skin burn and melt and makes your car melt because this highly acidic stuff hits. It's really, really dilute, so the pH of it's not super high. However, the article mentioned, and one of the questions, number 9, mentioned that now that our rainwater is a little bit acidic, now it reacts with and dissolves a lot of things that regular rainwater does not dissolve. So one of the things that it does is in the soil we have all these minerals, these magnesium and calcium, potassium. These are compounds and minerals that are in the soil. Normal rainwater comes and it leaves these guys in the soil, and these are important nutrients that plants need and stuff. But what happens is when the acidic rain comes, it actually reacts and dissolves these guys out of the compounds that are in the soil, and it does what's called leaching them from the soil. So these ions get taken away, and they become part of the rainwater system. And one of the things that the article got into was the aluminum ion. So the aluminum ion gets leached out of the soil, gets into the water system, and aluminum is highly toxic to fish. And so the article mentioned a lot how that was a bad deal. The high levels of aluminum, now the aluminum, what it does is the fish, it's toxic to them, so the fish realize, oh, this is an irritant, this aluminum stuff, I don't like it. So they build up a lot of mucus to help protect them, as a filter to help protect them, and if the aluminum levels are too high, the fish build up too much mucus, and that can suffocate themselves. So we want you to understand that this acid rain stuff is not as direct. It's not like fish is swimming around in water one day, rain cloud comes, it rains, the rain hits the pond, the fish is in, and the fish just dies. No, it doesn't happen that way. It's much more subtle than that, so we have to have a bigger understanding of how everything is interacted with other things. It's the buildup of aluminum that is in there that causes the mucus to build up, so the fish dies from suffocation, but ultimately it's from the acid rain. Now, there are some organisms and some things that are pretty sensitive as the pH gets lower. So you think about fish eggs and amphibian eggs. Those are very sensitive, and so a lot of your fish and amphibians might have a hard time reproducing if the water gets too acidic. Also, low pH, certain types of bacteria and algae might not be able to grow in low pH levels, and certain bacteria and algae are good things. Some of these other bugs and organisms here, certain organisms are more sensitive than others. So we see things like snails, they can tolerate a low pH, and clams. So if our water gets pretty acidic, we might see lots of those guys. But some of our other guys, like our mayflies and our trouts, they're pretty sensitive to pH levels. So we'll see them start to disappear as the pH levels get higher and higher. So those are a couple effects. Some other effects that the article mentioned is the effect on plants and trees. Again, it's not that the rainwater hits the tree and the tree wilts, but what it does is it dissolves that waxy coating. Now, that waxy coating was on the leaves to help protect them from fungus and bacteria, and now that that acid rain has dissolved it, that is being eroded away. So it's ultimately the fungus and bacteria that will kill the plant, but it's because of the acid rain that they were vulnerable to that attack because that waxy coating got dissolved away. We saw in our lab how acids will react with calcium carbonate. And calcium carbonate is a material that is in a lot of things, a lot of building materials. In our lab, it looked like a fine chalky powder. In fact, that's what chalk is. It's calcium carbonate. But also, marble is primarily calcium carbonate. Limestone's about 90% calcium carbonate, and of course concrete is made of primarily limestone. So we have a lot of these building materials that are made of calcium carbonate, and we've seen how acids will react with calcium carbonate. So a lot of our building materials get eroded away. You may have been to a really old cemetery where they used to use limestone as the gravestones, and you might notice that you can hardly see the writing in it anymore because it's been worn away from that. We've also seen that acids will react with metals. So they will corrode and deteriorate some metals. We get some lead and copper that might get into our water from that, or it might wear those down, or even some building materials that are metals. We see the acids reacting and corroding with those and wearing those away as a result of acid rain. You know, for example, Harvard has a bunch of statues, and some of them are made of metal or marble, and one of the things that they do every winter is they cover them up. And in this case, it's not protecting them from acid rain, but it's from acid snow. You might think, well, why is that such a big deal? Well, you know, when it rains, the raindrop hits it, it's on there for a while, it goes away, but the snow would just be sitting on that thing for days and days and weeks probably up there, so it can do a lot more damage. Here's just some other examples here. Here's a statue in New York City, again probably made of concrete, which is calcium carbonate, and you can see the effects from the acid rain on that, how much that's been wearing that statue away. Forests, especially forests high up in the mountains, can be very, very prone to damage from acid rain. And think about a high up in the mountain where you have like the forest is kind of in the clouds a lot. So those trees are just kind of soaking in those acid clouds and those acid rains. So they just have a lot more exposure to the acids than regular trees would be. So we see a lot of times they can be damaged much from those. So in the past, you know, people had short-sighted solutions to this. They're like, well, okay, let's just build bigger smokestacks. And of course, that's just passing the problem on to somebody else. So acid rain and our pollution, it's really a big issue. It's not just a state issue. It's an interstate issue, and it's an international issue because what one state and what one country does affects everybody else. Here's a little map here. You can see Pennsylvania right in the major zone here with our high pH because we have all of the old steel mills and all the factories in Chicago and Ohio and western Pennsylvania and even Baltimore and New York. No matter which way the wind's going, we're getting hit with our polluted. So we're kind of in the hot spot in terms of areas that are affected by acid rain. Now, the good news is that in 1990 they passed the Clean Air and Water Act, which really sought to control the NOx and SOx emissions, and we have made great strides in that. Here's some charts back in the early 90s. You can see the red being bad. You can see the high levels of the sulfur oxides, and we can see how much better it has been as a result of the Clean Air Act. So the scrubbers and things industry can do, we can do a lot to remove and lower our SOx emissions. Same thing for nitrogen depositions. Here's our nitrogen in the early 90s. Again, you can see all the red areas there, and you can see we've done a lot to get rid of those really bad levels of that. So again, there is good news. We have done a lot to prevent the acid rain problem once we understand it. And again, we want to make sure that we know what causes acid rain, the chemistry behind how it's formed, and the effects, because they're very subtle. We want to see how just that water being just a little bit more acidic, you know, there's not a big difference between 5.0 and 6.0 in terms of just measuring pH and how it would feel, but when we see the effects on the environment, just a small change there can be pretty big, so we want to be knowledgeable about that.